This nation will rise up, live out the true meaning of its creed. We hold these truths to be self-evident that all men are created equal. I have a dream that one day on the red hills of Georgia, sons of
So back we are for the afternoon. First, let's have a look on the schedule for the afternoon. So at 3 o'clock, we'll have Apache Beam. Then in second, we have April Group and Keros testimonial. On the third part, we have DRG and Snowflake testimonial and the Cloud Roundtable, and then the announcement of audience winner and individual awards. So for these awards, you have to get the vote. Is there everybody vote or not? Did you understand for the vote? So you have to download the app, attend the hub, and then you have to press on this button here, and then choose the one you want to win. So let's go on the first presentation. It's Google who is going to present us Apache Beam. For this presentation, I call William Van Benep from Group Product Manager.
Good afternoon. Thank you. I'm William Van Benep. I lead the product management team for big data, data processing analytics for Google Cloud Platform. And very excited today to speak about Apache Beam. And specifically, what's I think most interesting about Beam is it's really at the convergence of two of the most important changes in data processing right now, and two things which are core to both Google Cloud strategy and as well to Talend strategy. One being the move to streaming, and the other being the move to cloud and cloud-native scenarios. And Beam really is at the intersection of both of these dynamics. It comes from that background. I'll describe how we got to Apache Beam as it is today. And it is the realization of those in the context of the modern way of collaborating in open source with a large ecosystem and vendors. And so that's what I'm going to describe, why Beam is so important. And Beam is useful. It's a programming framework, so it's something that programmers use directly. But its influence goes way beyond that. Just like containers are useful not just people who actually deploy containers, but for the whole IT industry, Beam is useful for anyone who processes data at scale, whether or not they use it directly or they use tools such as Talend that generate Beam pipelines. And so the value is much, much broader than just value for developers. So I was talking about the background and how we came to this point. It all started kind of like big data in general, really started with MapReduce and Google File System and those early advances that Google internally developed in the early days of Google. When the first thing you do as a company is index the web, well, you have a scale problem. Even though the web of the late 1990s wasn't quite as big as today, you still have a scale problem, especially if you want to do it really cheaply and efficiently. And so MapReduce, and then after MapReduce, a whole suite of other technologies were developed internally and used by Google, but at the time, Google really wasn't interested in open sourcing of the technology. So we wanted to share the innovation, and so we published lots of white papers. There's some of them listed here. There is more, just to let people know that's what we're doing, that's what works, that's what doesn't work. We find it useful, and then internally we move on to the next thing and the next thing. And as this was happening, people in the industry, in other companies, reading these papers, running into similar problems, wanted to get their hands on those tools, but that wasn't an option unless you join Google and work in Google. And so a lot of these companies re-implemented technologies based on those tools, and that happened in open source. Yahoo, most famously, creating Hadoop by re-implementing Google File System as HDFS, and then MapReduce, and then Bigtable, HBase based on Bigtable, and Dremel based on Drill, etc. And from Google perspective at the time, that was fine. That's why we shared the white papers, but there was no direct engagement because, frankly, we had already moved on past those technologies to the next thing and the next thing. What's happened internally, and in large part due to the focus of Google on cloud, is that now we've joined those two streams. And so we've joined them technically, and we've joined them in the way we interact with the industry. So technically, internally, we used to have a thing called Flume Java, which was the replacement of MapReduce for batch pipelines. We had something called Millwheel, which was used for stream processing. And for reasons I'll describe later, we really wanted to unify them. And so that's Dataflow. But as we did that, we also wanted to do that in open source, because by that time, Google had changed the operating model. We still publish papers, TensorFlow recently, Dataflow, and a bunch of others. So that doesn't stop. But now we publish papers. We also open source the corresponding code. And so you've seen Docker recently. That's one example. You've seen TensorFlow. That's another example. Apache Beam is another example, with Dataflow as the internal name or the product name, and Beam, the name of the group in Apache that was created when Google and Talend and others got together because we all agreed on the value of unifying batch and stream and doing it in a portable way, got together in Apache to create a group. And so now, in a way, you can think of that as the rejoining of those two streams, no puns intended, those two streams of work, the Google internal stream, the open source stream, into a unified one. So just as easy to remember, why is it called Beam? Well, Beam is batch plus stream. That's where the EM comes from. It's also a good name, just in terms of things flowing. Like when you're on stage, there's always a beam handy you can point to. I like the image, but that's really the core of the name, and that's because that unification is so central to the Beam value proposition. And so let me talk a little bit more about the reason why aligning batch and stream is so important. One of them is that in many, many industries, people are moving from a very batch-centric view of the world to a stream-centric view of the world. To some extent, as an industry, we are unlearning batch. Like, we're at the point where, ironically, batch almost feels intuitive. It's like, yeah, you do things at scale. Of course you do it in batch. That's the natural way. And yet, there's nothing natural about batch. In the real world, almost nothing happens in batch. Things happen continuously. And somehow, after years and years of using the same tools, we kind of got in our mind that batch is natural. Well, it's not. And so I think we're unlearning that. And we're unlearning that because the tools now make it much easier. It used to be stream was hard and stream was expensive, and it was only as a result used for the most advanced use cases. That's not the case anymore. And so industry by industry, either because new sources are natively stream-based, mobile applications, sending updates, IoT, plenty of new things, new data sources that were not instrumented before, now send data in stream mode, and so you have to be able to receive and process them. Or some of the existing sources are slowly transitioning from batch to stream. But that doesn't happen instantaneously. It takes time, and you cannot just snap your finger. And so you have to have an architecture which can keep working through this transition, and as your sources, as your partners upgrade, as they deploy more real-time infrastructure, you need to be able to work with them. And when that happens, you don't want to re-implement your logic. You don't want to do the work. You don't want to take the risk of having a slightly different business logic. And so in that context, it's really useful to keep the same pipeline and just redirect it to a different source, and voila, you have the same logical processing now in stream mode. Another aspect is that the unification of batch and stream makes it really easy for you to kind of tweak the operational model. And that's something I see quite often that really, really pains me, is when a customer has built a data processing system, and it works, they built it, they debugged it, it does the job. And then they say, oh, we have to change it. It's too expensive, we want it cheaper, or it's too fast. Sorry, it's too slow. Too fast is rarely a problem. It's too slow, we need it faster. Or it doesn't scale enough. It works well, but now we have 10x the volume, and it doesn't scale. And in those situations, over and over again, you see customers re-implementing. It's like, OK, now let's do a V2 version with, let's use a new stack. Let's use, maybe a new language, a new tool. And that's just painful, because if you have code that's been tested that actually works, you don't want to throw that away. You want to be able to change operational concerns, like the cost, like the speed, like the scale, just by kind of turning a knob or choosing the right underlying runtime, but that should never be a re-implementation effort. And so that's why unification of batch and stream gives you, is it lets you decide based on the cost trade-off. Because in practice, stream usually still costs a bit more to run. When you run things in batch, you can optimize. And so there might be cases where, even though you're capable of running in stream, you want to run in batch because you're reprocessing, 2-year-old data. You don't care if it takes 2 hours or 3 hours. You just want to get done efficiently. So unifying batch and stream gives you that flexibility. And another use case, which we see more and more, and it's very central to the reason why Google internally uses Beam so much, is that we do so much machine learning. And in machine learning, one of the cardinal sins is not having a consistent data preparation pipeline between training and scoring. So you prepare the data in your training data, you train the model. When you actually use that model to bring new data for scoring, you absolutely have to prepare the new model in the same way you prepare the training model. Otherwise, it's just apple and oranges. Like, you can get some really bad results. And so that's another place where you want batch and stream in one pipeline, because training typically happens in batch. Scoring, on the other hand, using the model, sometimes it's batch, sometimes it's stream. And again, via Beam, you can use that same pipeline that you use at training time for prediction. So these are some of the use cases. There are many more. Why it's so important to break the delta between batch and stream, and that's what Beam is designed for from the very start. And the way Beam does that is by acknowledging a fundamental truth, is that there are 2 times. There is the event time, which is when things actually happen in the real world, and there is the processing time, which is when your application receives the event. And as long as you fool yourself into assuming the 2 are the same, you're not going to efficiently and reliably be able to do stream processing. And the heart of the Beam model is the recognition that those 2 times are different, and the fact the programming model makes that a first-class part of the model. And so here in this diagram, if you look at the dotted line, that is the x equal y axis. No, it doesn't go through the center because the 2 axes are a bit different. The green one starts at 12:05, the other starts at 12. But basically, if you live in a perfect world where events arrive immediately in order, every data point would be on the axis. There is no situation where data point is on the right side unless you've broken some law of physics. Usually, it's all on the left side somewhere, either very close to the dotted line if the event comes very, very quickly, or far away. And sometimes we're talking milliseconds, seconds, sometimes we're talking hours. If I'm skiing with my phone, GPS app on, and I go in the back of the mountain and I lose network connectivity, well, the GPS keeps tracking my position, but it doesn't upload. And then I go around and I reconnect, and then suddenly you get 20 minutes worth of data point. And obviously I did not ski down at the speed of light. I'm not that good, but the application receives all of that at the same time. And so it could be a large delay. And so the way Beam does that, and I'm going to give a quick overview. I'm not going to show any code. This is not a technical tutorial. This is just explaining the philosophy of the Beam model and really helping understand why it's so helpful. The way Beam handles that is by breaking down your logic into 4 very distinct portions that you implement separately. And so instead of having some spaghetti code that deals with buffering and late events and windowing strategy all in one place, that's unmaintainable and application-specific, you have a very clear separation. What are you trying to calculate? Where in event time, it's like in the world of when things happen, what grouping do you want? How do you map that to the real world? And then how do you deal with late events and things that you just cannot stop from happening? And so the first question is what? And this just says, you have all those events, they're grouped in whatever way you want. If it's a mobile application and you have players in different teams doing interesting things in the world and winning points, and then all those data points come together. You want to group them by team, maybe by geography, and then you want to add up all the points in the team. And so that's very simple here. All those data points arrive, and you just want to add up a total value. Okay. Obviously, most of the processing is more complex than adding. The key thing is that you define the processing in one place where you don't worry about streaming, you don't worry about windowing, you don't worry about anything. Just define your calculation. Then the where is where in event time. And so now you're saying, forget the real world. In an ideal world where every event is immediately available in order, how would you want to create windows? Because you don't want to just add up events forever because it never ends. You want to add up points for time value. So here we have a 2-minute window, for example. So every 2 minutes you add up all the data points and you get a result. Again, very simple example. Just to illustrate, the key thing here is that the place where you define this windowing, and whether it's a fixed window or a sliding window or a session-based windowing, there's plenty of ways you can ask for the windowing to happen. You define that separately from the calculation that takes place. And that's where the real world intrudes. Now you have to map that to the fact that in reality, things don't arrive on time, and events can be delayed, and can be delayed for a really long time. There's really no way you can ever be sure that you've received all the events. There could always be something that was delayed. And so what do? Do you wait forever? Well, not really an option. So what you do is you have to decide for each window when you have enough data. And that's another benefit of Beam, is that the system has heuristics based on a lot of experience that we have internally at Google running streaming system that help you make a really good guess based on data that goes through, based on signals from upstream system, a really good guess about when you have enough data for a given window. And so we call that the waterline, and you can tell the system, use the waterline, and when the waterline hits, calculate for that window. Or if you want to do it yourself, you don't have to use the waterline, you can use your own mechanism. And so now you're in streaming. Now you don't wait till the end of the world to get your results. You can get your results step by step as things happen. And that's great, that's useful. The one issue is that a watermark is not perfect. This 9 arrived way too late. It got missed. And the 3 here, like the third window, we could have triggered, which is the term for, we could have calculated the value quite a bit before. Like we waited too long to calculate the value for that. So we could have had faster results. And so that's where the last part comes, which is the part about how. How do you deal with refinement? And so that's the last part of the Beam model. Again, separately from everything else, you define what you want to happen when a late event arrives. And that really depends on what your application does. If it writes to a database, you can probably update. If you send notifications, well, that's different. Can you recall them? Yes or no? It depends on your system. Do you want to send an update? Maybe you want to discard that late event. That's fine, but that's your choice. It's an explicit choice, as opposed to less organized streaming framework where things get dropped just because it's too late. There's no way to handle it. If you want to drop the late events, that's fine. Just be explicit about it. Similarly, you can also trigger early. So you can set rules that says, even if the watermark, if you look at the window number 3 here, even if the watermark hasn't been hit, I still want to get results early to get an approximate value, and then I'll keep triggering again on the watermark and when late events arrive. And so, everything I described, this actually maps to pieces of the Beam SDK, where you explain that. And the value of breaking it, one is it makes writing code much more effective. The other is that this is what also allows the same pipeline to run in batch and stream. Because when you run in batch mode, at the very start of the job, you already have all the data you're going to process. And so you don't care about when in processing time. You're just going to calculate everything at once. You don't care about the green one. You don't care about the red one. But the business logic described in the top 2 is exactly the same. And so Beam guarantees that if you run a pipeline in batch mode, or if you run the same pipeline in stream mode, and that pipeline over time gets the same events, you will have the exact same output produced by the pipeline, because it's the same code and the same logic. And so that's how Beam, really from a programming perspective, makes developers effective. But the value goes beyond developers. Everybody who uses a tool that generates Beam pipelines get the value that now they can choose the underlying runtime. They can choose one that's optimized for stream, that's optimized for batch. or they can choose one that works. OK, there we go. And they can, and so that's where the portability comes in as a complement. So there is functional flexibility, batch or stream, and then there is operational flexibility, meaning you can deploy on the engine of your choice, including one that's optimized for batch or for stream, as some engines tend to be better at one thing than the other. And so that's the other thing that's very unique about Beam. And the way this works is that the Beam framework defines a portability model that allows you to mix and match many aspects. One is programming language. And so today, there is a Java SDK for Beam. There's a Python SDK. Our friends at Spotify, who use Beam a lot, have created a Scala SDK called Shio, which runs on the Java SDK. And then there's a Go SDK in the work, and more to come. And so you have a choice of programming language. All of those follow the Beam framework, which means that they can then execute on a set of runners. And so what we call a runner is really something that can take a Beam pipeline and run it. There is, as part of the SDK, there is a single node runner, which is really not meant for operations. It's really meant more for debugging and just experimentation and learning the model. More importantly, there is a set of highly scalable runners, which I'll discuss next. The one thing I'll add is that the Beam model also brings a level of interoperability under the cover as far as the task execution. And that's what allows mixing and matching transformations and source and sinks in different formats. So you can have a Python pipeline that will be able to use a source that's written in Java, for example. And so there's a lot of flexibility. You can bring C++ code that you want to execute as the node-level execution. Lots of flexibility there. So there's a lot of work in Beam in that portability model, and that's really unique about it as well. And so in practice, what does it mean? Well, these are some of the main runners that are available for Apache Beam. So I assume you all know about Apache Spark. And so there is a Beam runner for Spark, which allows applications, whether you wrote them yourself or a tool like Talend created them, you can run on a Spark cluster. Those of you familiar with Apache Flink, which is another Apache project, another large-scale distributed engine, which also can do both batch and stream. It's really more focused and optimized for stream, but has both capabilities. And the Flink model is actually just the native Flink model is very, very close to the Beam model. Like the team at Data Artisan who built it and who built the runner, it was inspired by the paper. And so there's a very clean mapping between the two. And then there is Google Cloud Dataflow. So now that's one of my products as a Google Cloud Platform product manager. This is, from the Beam perspective, it's just another runner. It's just another option where you can deploy your pipeline, deploy again, whether you generated it yourself or a tool like Talend generated it. What's unique about Cloud Dataflow? It is a cloud-native service. It is a serverless system, meaning you don't have a cluster. You don't ever have to deploy anything. You don't have to scale anything. You just tell us to run the job. In Spark, in Flink, well, you get a cluster, and you run the job in the cluster. With Cloud Dataflow, you just submit the job to an API, and either as a stream job or as a batch job. And we, under the cover, provision whatever resources are needed for the job. We continuously auto-scale the job. So if it's a batch job, we start it with a certain number of workers. Depending on where it is in the pipeline, you might need more or fewer workers. And so we dynamically scale the workers. We have some really advanced optimization. We do straggler detection. So if a worker is taking too long, we can reclaim job from a worker, give it to other workers. We have a distributed memory shuffler. Like there's a lot of internal technology because we run petabyte and petabyte every day on those systems. And so any optimization from a Google perspective saves a lot of money. And so we bring this optimization to this managed service. And so in batch mode, we'll auto-scale it. And then as soon as the job is over, all the resources are reclaimed, and you stop paying. In stream mode, the job stays up forever, or at least until you shut it down. And depending on the traffic and the work, we auto-scale the workers. And so again, it not only saves you from a lot of work, it also optimizes resource usage because you're only paying for what you're using and not overcommitting to more than you need. And so it's quite unique in a way, but again, from a Beam perspective, it's just another runner. Just a place where you can bring your Beam pipelines and execute them if you want to run on a cloud-native service in Google Cloud. And in that context, it's part of a larger set. The serverless aspect, which I described for data flow, is true across the entire platform. It's one of the key differentiations of Google Cloud, where something like Cloud PubSub, for example, which is an event delivery system, similarly serverless. You don't create a cluster. You just define a topic, you set permissions on the topic, and then you're done. If there is no traffic, you pay nothing. As traffic goes up, we scale it up, and you pay just for what you need. And everything is automatically received on the nearest point of presence on Google's global network, and then goes onto Google's private fiber to the nearest cloud data center. All of that is automatic. And so, and it's used very, very often with data flow. Events being collected, like Spotify, for example, everything that happens in the mobile app all over the world, it flows through Cloud PubSub into Cloud Data Flow in streaming mode, and then typically into one of our storage systems, typically BigQuery for analytics. Again, serverless Cloud Data Warehouse, both infinite storage system. You can just create tables, and you pay exactly for the tables you use. You can stream data directly into the tables, or use BigQuery for analytics. And the reason why you see data flow both places, in the life cycle of the data with the little Beam logo, it's the same product. But because it can run in stream mode, it's used quite often upstream, preparing data, doing real-time analytics. It can also be used downstream just to do batch mode processing on data on all the storage systems. So I'm not going to give you the total breakdown. I'm happy to talk at the break about Google Cloud. But the main point here is that the serverless aspect of data flow is one example of a larger 100% serverless platform for all aspects of Google Cloud. So for more information on Beam, the Apache Beam website, it's Apache. Everybody's welcome as a user, as a contributor, bug report, documentation, anything is welcome. There's a thriving community with some meetups being organized. So please, join us and see how Beam can help you. Link about Google Cloud, the paper. So at the time, it was called the Data Flow paper. We renamed it because Apache doesn't want its projects to be named after commercial project, and so Beam is the renaming. So we now call it the Beam model, even though the paper calls it the Data Flow model. If you're welcome to read the paper, especially if you like to read academic papers, I would actually recommend reading these 2 blog posts by the same author as the paper, which are really much easier to read and really do a good job explaining what I try to quickly describe about how the Beam programming model works. And that's for those who are interested in understanding how Beam works. Again, this is not a code tutorial. This is really the philosophy of the model. I think it's actually important to understand, even if you're a user of tools and you never write pipelines yourself, because a lot of the value you get from this platform flows from the philosophy and the architecture, both batch and stream alignment and portability that Beam brings to the table. And so, in conclusion, please join us. Join us on Beam. Join us in Google Cloud if you want. And thank you very much for the opportunity.
Thank you very much, William, for this presentation. Thank you. Convert the promise of big data into real-world result is with Denis Baudon, CEO, April Technology, Benoît Bourdet, Solutions Director, Keros, and Julien Le Tessier, Project Leader, April.
Hello, everybody. Hello. Pleased to be here. Let me introduce myself. I'm Benoît Bourdet from Keros. I'm leading the solutions inside Keros, and I share the floor today with Mr. Bourdon, with the CEO of April Technology, and Julien Le Tessier, who is project leader in April Technology also. So let's go. Well, the way we are just pushing something in front of you today is that it's quite hard today to go and to grab a lot of data inside the data lake to provide some value. All the IT leaders are saying that it's not easy to do that as a day-to-day basis. You can look here. You just heard a lot of things today that it's easy. It's you've got the data lake and a lot of things, and thanks to Talend and all the other technologies, you can grab the value and push all these within a lot of use cases. It's not easy at the end. It's quite frustrating for all the people, business people, working as a day-to-day basis in front of their customers or consumers. They are convinced that it is so precious to use all these data together in order to leverage the value. But as it's not easy, and it's not coming at the end. So if we could fuse all these data and data science together in order to be able to have and to leverage the value in front of the customer, it could be great. Okay? How many people here have got some data lakes or big data environment? Okay, great. And how many people here are using this data in front of their customer for their users as a use case somewhere within call centers and so? Great. It's not so many. So where we can go now is to say, OK, we've got a lot of technologies. You see that? And we just packaged a lot of technologies inside a single solution called C2X, Customer Experience Excellence. I have to say that we, Keras, did a lot of jobs in order to package all these elements together in order for you to be very fast on the market, to have a great go-to-market at the end. Of course, Talend is precious. This is perfect choice for C2X. Okay, it connects from everywhere, native for big data. We did a lot of jobs with Talend, and it's great for us to package it within a global solution with Cloudera and Qlik. We use all these together. Okay, but at the end, we are talking about technology. We are talking about deep things to install, and it's not so easy at the end, as I was saying before. So our approach is this. You can just avoid losing a lot of time, spending a lot of time to connect all these technologies together in order to go on the business challenges at the top. Okay, so if you use our solution, you will earn and gain a lot of time in order to go directly, and we will see that together just after, and just to be sure that we will spend some time for the people, for the user, for the consumers, and not for technology matters. So the value at the end of C2X is to be reliable, secure, and scalable platform, of course. It's our job to do that. We've got some advanced experts and data scientists, but not only data scientists, also some business analysts able to help companies like April in order to grab the real business value at the end. And of course, it's all-in-one solution in order for you to go on all-in-one project approach. Sorry. Yes, OK, thank you. Business benefits, we saw that. And the IT benefits are here. It's all-in-one solution again. It's robust, align IT, everything in one global solution in order for you to be very fast. So now I can just, the floor is yours.
Thank you, Benoit.
Please.
Just a few slides to explain who we are. April is a worldwide insurance company. Our 4,000 staff members operate in 31 countries, and our turnover is almost 800 million, and we hope 1 billion in the next few years, of course. We have a unique model, business model on the market because we are insurer, like those you know, like AXA, Allianz, and so on. We are also a wholesale broker. A wholesale broker design products and service insurance services, manage policies and claims, and our last activities is as a distributor. So we sell product through an open, large open network, broker network, 20,000 brokers in the world, and also with our own network, agencies, e-commerce website, or call center. We have a large range of products, but with a specific position on health and individual protection, P&C, property and casualty, legal protection, and mobility and assistance in international way. Our ambition is to make insurance easier. So directly connect to the topics of the day. That means a better understanding of our clients and their needs, well-target products, and of course, omni-channel approach. So, in March this year, the question was how to use our precious data assets, and it was the beginning of the C2X journey with Talend, Click, Cloudera, and Keris. So now, Julien.
Thank you. So first we did a brainstorm with the companies of April Group, and we finally decided to go on to build a recommendation engine to increase the cross-sell and upsell for the agencies network. So in order to build this, we had three main sources. One is called PRM, Prospect Relationship Management. It's a master database that is giving us a unified vision, 360-degree vision on the April customer. That means 1.7 million customers and around 5 million live customer interaction. So we had this master database that we combine with the legacy back office of the agencies, AG Pro. And then we decided to enrich this with open data. So first you have to put the data into a Hadoop cluster. We use the Talend Big Data for this. And we also enrich and approach the data to have a combined vision of everything. About the open data, we had demographic and real estate data mainly. So when you build this, afterwards you've got, for one customer, 500 parameters, and you can then build the recommendation engine on top of this. So we used several algorithms, and we combined them with the marketing input. So the marketing gave us 5 main key indicators for every market: health insurance, car insurance, for instance. And we combined it with two types of algorithms that are random forest and collaborative filtering. So collaborative filtering is the probability to have one or several products in the market for upselling, and random forest is for cross-selling. So, Benoit?
Okay, let's have a short demonstration. It's only 2 minutes. What we've done, it's the first series of screens we've done. So here we can see that we've got the client, the agencies, and the market, and we tried to have 3 use cases at the end. So the first use case is about the client, so it's a 360-degree view, and you can see that we've got recommendations. Sorry, it's in French, but I think you will understand pretty well. Recommendation here, and all these recommendations are coming from the C2X environment. Okay, you need all these to push these recommendations together. Then after we just thought about a way for an agency leader to prioritize all the prospect pipe and the client pipe. So it is another direction, is to say, okay, I've got 3 sales. Where do they have to go now next week? What are the better opportunities for them in order to leverage the business and to be the more successful as possible? Okay, so it is another use case, and we used the same C2X in order to leverage this use case also. And then at the end, we've got also the market leaders, and they need to, they need scores in order to target better. Okay, so they will have also all these prediction matters in order for them to use to choose between several departments in France, for example, in order to score and to target the good campaigns or the good departments. Here you've got a panel of what is available for them in order to choose the right value and to go on and to leverage the final value in order to have the better campaign as possible. Okay?
Thank you, Benoit. So this click sensor report was built in 60 days among Hadoop cluster loaded with Talend big data. And we added some Spark for the recommendation engine and the algorithms. So the use case was cross-sell and upsell. And for the project, we had the first iteration that lasted 60 days. We've been able to demonstrate the ClickSense data viz tool. Then we focused on a market recommendation approach and did another version of the recommendation, but will be deployed in a subset of the agencies in order to prove the value of it. So the idea is to recommend, as we've seen with a bar chart, what is the probability of someone wanting a car insurance contract, for instance, and then it says to the agency seller why it recommends this, probably because of his age, for instance, or his family, several parameters. So it's a way for the seller to challenge the validity of the algorithm and to improve them on the long term.
So it's a kind of a white box,
yes,
opposite to a black box.
One word on Talend Big Data. We've been mainly user of Talend data integration for data mart, data warehouse project, a classical BI project. And I must say that after Keris did all the first iteration, it was really easy to implement the Talend Big Data part because it's really like Talend data integration. So the next steps are probably to extend those data, enrich with other sources because we have many other back offices, and so we will enrich the recommendation engine.
Okay. So thank you very much. Thank you for your attention. I was very pleased to be in front of you. Thank you.
Thank you.
Very much. Thank you.
Thank you.
Here is our next presentation, and it's timing with big data in healthcare with Snowflake testimonial. And it's Paolo Forlani, Big Data Platform Architect, DRG, who's with us. Thank you very much.
Hi, everyone. My name is Paolo Furlani. I'm a big data architect at DRG. And today I want to talk about our journey to big data, starting from scratch because our company wasn't actually in the big data at all. But I want to talk about solutions and different type of technology that help us to deliver a successful big data platform that actually we expose to all our company, and we are delivering actionable insight by using the platform. But first things first, who is DRG? So DRG is a primary provider of analytics and in the healthcare industry. We are doing a lot of analytics in the space for delivering for the pharma industry and biotech and medical technology companies. And DRG is one of the fastest growing company in the United States. We are 48 of the top 50 life company are actually our customers, and we are having. And we are delivering all the insights. We are having also many of the we are having nowadays more than 1,000 employees, and we are having a complete solution for most of our customers. We are also a global company because we are present in 6 countries, 17 offices around the world, and we are 75% of our analysts actually have an advanced degree. I came from the big data world. Before that, I was in the data warehousing, and then after I was looking for massive parallel processes, and those things brought me to the real world data. And at this point, DRG, it was 1 year ago, substantially, in a very critical point because the competition in our market was pretty tough, and we needed to have a competitive advantage that will deliver our kind of analytics to our customers. And that actually happened to be big data. Big data for us really means electronic healthcare records and pharmaceutical and medical claim data that we merge into our analytics to deliver top of the line analytics to our customers. But going to big data was obviously a challenge for us because the company traditionally was not really ready for a large amount of data and this kind of fast processing. So our infrastructure was not really ready for big data. And coming from my experience working for different companies implementing big data, mostly on Hadoop and on premises, I knew very well that building a big data team is not an easy thing to do. given the competition of pretty much every other company out there trying to go in the big data sector and leverage this. So it's quite difficult to find a good developers, and the overall enterprise is quite costly. And also, the other things that I was very clear on it was that some of the solutions that are mostly used in the big data are quite complicated, and also they are difficult to integrate. There are so many projects that are doing something really well, but this is not necessarily something that is easy to talk to each other and between these. So the integration is definitely very hard. And at the same time, as you can imagine, once our company was very clear in the roadmap of implementing the big data, what we call real-world data, there was a lot of pressure to move very fast. So we already purchased more than 14 terabytes of data from different providers around the United States, and we needed to leverage it and to allow our analysts to create their competitive analysis there. And so the initial challenges we have obviously was the fact that most of our analysts, as it is in many other companies, is that they were knowing very well SQL, but the SQL obviously needed to work now with the big data. We had several early tentatives of leveraging big data on traditional databases and with a traditional methodology, and it didn't quite work very well. Now we are having even a large amount of data, and that was causing a problem. So the point here is that we needed to have a platform that deliver a kind of fast queries on a very large scale of data. And the third element here is that we also the rest of our architecture was already infrastructure was already in the cloud, but it was a more type of web application that we were using to deliver analytics to our customers. It wasn't really a big data. So the question here was, is this platform really existing? Doing sophisticated SQL and doing it in a way that is scalable. So what we have ended up to, of course, is to do a lot of POC, and we compare all the potential candidates out there. And after different POC and putting together and comparing the performance and the flexibility and many other elements there, we landed with Snowflake. Snowflake is a really amazing platform. And just a few words about what Snowflake is. You probably already read about it, and you can definitely more. But I want to give you my sense to why we have chosen Snowflake and what is actually our main criteria behind that. So first of all, Snowflake is a platform that has implemented. He has substantially separated the three major points of the application: the storage, the computer, and the rest in a very good and scalable way. So the data is substantially on S3 at this point, and there are plans for moving also not necessarily only in AWS, but also porting to different from different providers in different clouds out there, and the fact that the data is on S3 is very, very important, because for a company like ours and many others out there, S3 is substantially unlimited. So we actually don't need to plan for data growth and all that, as we used to do it in the past, when we used to do in a traditional databases where you needed to plan for the next 6 months to a year, and then most of the time you wanted to buy and purchase new storage, and that was kind of complicated, and you needed to keep up on that. In this world, you don't need to. Like, your data is as big as you want, and obviously, the more you use it, the more you pay. But this is exactly what is your business model, right? You want to use the data for improving your analytics. So here, the second part of it is obviously the compute part of it. And unlike different type of platform like this, even including Hadoop, the separation between the processing layer and the data is very clear. So now, not only you can create a scalable set of clusters that actually does perform the analysis that you really want, but at the same time you can create multiple of them, because there is no really data movement, there is no any connection between data and processing. So now your data is always shared in S3, and now you can create multiple. Like we do in our company, for example, we have a set of clusters that deliver substantially the ETLs and all this processing that are done either in a batch mode or in a more continuous through the day, because the other part of the story is that all these the different clusters that run at the same time, they don't really compete for resources. They are completely independent set of clusters, mostly on EC2 machines that are in the cloud. And once your query is done, or the cluster is not anymore needed, there is no data that was stored on those machines. So you can create as many as you want. And in our case, for example, we are creating multiple warehouses for the ETL, like I said, and one big warehouse mostly to service our analysts. And many others for different other purposes. For example, we have a situation where we also deliver some of the data directly to our customers, so we allow them to come in our system, and they can run the query in a dedicated set of clusters that are completely isolated from the rest of the company performance and the rest. So we really don't impact each other, and at the same time we can deliver consistent performance to our customers, which is exactly where we want to be. And the third layer here is essentially the rest of it, right? So when you do the optimization for your query, the management of the different data parts, and then the most important thing is the transaction. Because one of the things that Snowflake deliver, which is unlike many of the big data solution until now, is actually asset compliance, which is a big thing if you compare with the equivalent situation in a more traditional big data platform, like for example, Hadoop and Hive and all that. Here we are doing queries on top of really big data. Our query return in a few minutes. And we are scanning many terabytes of data a day, and we can do this in a transitionally consistent way, so that we can run the ETL through our day as the data comes in, and the customer will always, our analyst will always have a consistent set of view of the data. So this is really coming together in a very amazing way, and Snowflake is really amazing because of that, and because of many other things. Like, for example, they have time travel kind of query where you can run a query as of a couple of hours ago, or maybe like what was in the morning. So if you have an ETL that modifies some data, you want just to restore to the previous version of the data, you can actually do that, which is another amazing thing. And then there are other things like data cloning without data movement, which is actually amazing in itself. So you can create a situation where you can test your data, and you can have a full replica, if you want to, of your either tables or schemas or database, even entire databases, and just take a few minutes to have basically your data clone, because there is no really data movement. Everything is happening in the third layer, the one that is on top there, that keep track of what set of files substantially is attached to that particular table, for example. And there is also, lately, they launched, for example, data sharing, which is even the next generation of data delivery, for example, where you can actually take, carve out a piece of data in your system, in your production system, and you want to deliver this to the customer, to one of your clients, for example, and so you ask them to go to the cloud and just open an account, and they can come and look at your data without data movement, so that is 100% consistent, and at the second after you move the data in. So definitely Snowflake is our SQL engine of choice, and we are using it for over almost a year now, and performance are absolutely amazing, and scalability and flexibility is really unprecedented in my experience. So the second part, obviously, of the equation here is that once you have solved the problem of the SQL engine, then you will want to have data, obviously, that is refreshed, and is refreshed in a consistent way. So this is now a data integration problem. A data integration problem is still with a big scale, because we are still talking about big data and all that. And given that, for example, one of the early tentative of using this data in our company before I joined was using more traditional type of technologies, like, for example, they were using SQL, Spark SQL, and those kind of technology. And those technology, they are amazing, but they are also they do not support CRUD operation and transactions and consistency. So you always end up to do basically a full load of a sort, either of all your data or part of your data, because you can't really drill down into a specific set of transactions, for example. So that was the other part for us. And of course, the solution of that was Talend again. Given my prior experience in the big data world, this was, as I was mentioning before, more traditional, Hadoop environment, I knew very well that Talend can deliver performance, and can deliver flexibility, and can give us all the rest of the things that you really want when you move the data into the database, into any database, which is the monitor, the alerting, and all the stuff that you need to code yourself. If you wanted to hardcode an ETL, you will need to hardcode for yourself or that. So and Talend give you all that. And at the same time, also, Talend really helped us a lot, because at the same time, once we have chosen the SQL engine, we also needed to build a team for the ETL now, because in our company, we used to have a group of DBAs, and some other were more on the data science side of it. So we really didn't have any developer that can help us to move in a consistent way, refresh the data as we need it, because obviously the solution of doing a full refresh is not doing a full refresh, so doing an incremental to at least a day frequency or even less. So how do we do that? We do this with a tool that has all this workflow management and all that. And Talend obviously is an excellent choice for that. Many other people were already said at this point in many other talk, but these 900 plus components, they are really what is the bread and butter of Talend, and help you in many different situations that if you would need to code yourself, it will be challenging if there will be a new problem that you need to solve, and now you need to code first, you need to debug it. So working with a Talend tool is actually not only helpful for moving ahead much quicker, but also is almost as if we added to our own internal developer, Talend developers, and not only that, so that they can move much faster when, for example, new project, new technology are coming alive, they are always going faster, ahead of us. So we don't need to learn all that new technology because they can do it. I heard in different talks, different technology, and Talend is one of the quickest to implement this. So focusing on this platform actually is helping a lot because we don't need to learn ourselves all this up front. So this, we had a lot of flexibility in choosing our developers, and in a very short amount of time, just in few months, we scaled to 10 developers at this point, and we found really remarkable people on that, because if you are working in the data integration type of any type of tool, you will pick up Talend in no time, because it's really using standards that are spread through the sector, right? So the ability of doing a very little coding will allow us actually to move very fast, and in a few months we were able to bring all our major data set into production. And we are now delivering, we are just working on the next generation of smaller kind of side data set that we still want to have that, because the final vision obviously is to have everything in the same framework. Here is pretty much a vision of the architecture as it is. Here I depicted the main part of it. As you can see here, Talend is right in the center of it. And we are using Talend Studio, but also we are using the integration cloud side of it. This is actually a kind of easy to work with that. The beauty of using Talend Integration Cloud is that you will not only run your job in the cloud, so you can have scalable performance and all those related things, and scalability and all that, but at the same time also the infrastructure itself is in the cloud. So we can just we can just write our job in the Talend Studio, and we can deploy to the cloud, and after that we just needed to schedule, and that will run our jobs in the cloud with a flexible performance, because you can run as many as you want, and you don't really need to redeploy your infrastructure, because now you needed more power, or you needed a different type of framework. So we are pretty happy with that environment, and that is the center. So for example, most of our data is in flat files when we start, and flat files will be probably like compressed and all that. So Talend is taking care of that, is taking care of applying our data cleansing and all the operation that we want to do, because our data is pretty dirty, being real world data. There is so many sources. There is thousands and thousands of sources of the data, and they all have different corks in it and all that. So we are doing this, and we are doing the cleansing in Talend, and after that we are deploying the file on S3. And we use, again, Talend to orchestrate jobs that copy command, in this case here, which is the fastest way of moving data inside of a Snowflake. And Talend help us to orchestrate these copy commands, so we move very quickly data from S3 into our staging tables and all that. One thing that we do with Talend also is to split the files into a smaller chunks, so that we improve the performance of the copy commands. Obviously, all this is pretty simple. We can do this just with the parameters, and we can change the way we move the files and we split the files. And the third part of it here is also for data processing and for machine learning jobs. We are leveraging Spark here in a big way. And one thing that I want to bring your attention to is actually the fact that all these components, they're all linked, and that is actually what allows us to do a lot of flexibility and different type of things. For example, obviously Spark is very well integrated with Parquet, for example, on S3. That is in the core of Spark and Spark SQL, but also is very well integrated with Snowflake, and the connector with Snowflake is very, very sophisticated. The ability to have a query push down is really, really amazing, so that you can write actually job directly in Spark with the Spark code and syntax. And this will be transparently translated into a set of query that run actually on Snowflake, which is the best engine here for delivery of the data very fast. So this is all transparent. You run Java code, a Spark job, and this will be actually translated into a set of query that actually are pushed down directly into the Snowflake, and that actually is what really you want. No data movement here, or a very minimal data movement. This is exactly what you want. And on the right side here, as you can see, we are for example, we are delivering a couple of hundreds of Tableau dashboard there. Our analysts are using the web UI, which is a very sophisticated UI, very sleek, easy to work with, to interact with Snowflake. Obviously, we use the PySpark for different type of simpler machine learning or algorithms of that sort, and of course JDBC or DBC. So these are the main part of it, and they are all pretty well integrated, and we can plug and play whatever we needed in that particular situation. For example, if you want to deliver a very big amount of data and you want to crunch it very simply, you can use Spark. And Spark in Talend is also native on Spark, so you can write Spark job, as obviously everybody knows at this point. We also use Databricks for other machine learning. We plan in the future to use more AWS EMR, because integrate very well with Talend. And here I just wanted to show you a little bit of that, just to give you a glimpse of what we have learned through the implementation. In just few months, we were from zero until we went to production with our main data set, and it all worked with a very, very few hiccups. So some of the things, so for example here, just you can see on the left side here, there is just the TAC engine, which allow you to connect to the Git and handle the part of the connection to the Talend. In the center on the left there, you obviously have our set of EMRs for development and production, and of course the S3 part of it that is inside of our VPC, private cloud, and on the top there you have two remote engines. Remote engines, as you know well, they are the one that allow you to run either inside of premises. If you want to access, for example, a database, you really don't want to do it directly from the cloud. But at the same time, also you can use it to do a special operations. For example, that one of the things that we learn is that if you really want to run a very extremely big data on the TIC environment, on the Talend Integration Cloud, there are some limitations in terms of storage that is available on those EC2 machines. And if you want to work around that, we can use our remote engines, where the difference is potentially that the remote engines is something that you manage, and you can create as big as resourceful as you want. And here in the middle we have the typical cloud engines that run in the cloud in the TIC environment, and all this is well integrated. The challenge that we have, like I said, a little bit of limitation in terms of the storage on that side. We are working with Talend to improve that. But one of the things that we learn also is that because of the way that the cloud engines are working, there is not really any data cleaning of the temporary file that you may create through your ETL. So one of the things that we learn is actually that you need to implement yourself, the data cleaning, so that through the data flow, once in your workflow, you in certain step you will want to go back and clean some of the data, so that your data now, your cloud engines are lean and they are not potentially run out of space. So that is the main things that we learn. But for the rest, we are pretty happy with Talend Integration Cloud. It worked well for us, and we are in a cloud also for that. Just to finish with, Snowflake is definitely our data, SQL engine of choice. AWS, our data lake is replicated there in Parquet files, and we use that also for disaster recovery purposes. Talend is connecting all together, and what we want to improve more next, it will be more sophisticated type of analytics by using EMR and Spark cluster, and streamline that part of it, and see what actually Talend can help us with that side, where we can actually do this without much coding. So thank you very much.
Thank you very much for this presentation. And now it's time for us to go through the round table, insight and advice for a cloud-first strategy. And I have the pleasure to welcome on stage Marjorie Payon, who is a presenter on the French channel 24. And she will be the moderator of the round table with her guests Jeannette Lind, Roy Hassan, and François Avedian.
Thank you very much, Laurence, for your introduction. And actually, yes, we're about to deep dive and learn more about insights and advices for cloud-first strategy. And we have the opportunity to sit with two clients of Talend to do so. François Avedian for Neospheres and Katie Staley for the University of Pennsylvania. And a partner, Roy, that's you. And you're, of course, working for Amazon Web Services. We'll come back to that in a few seconds. But first, good afternoon.
Good afternoon.
I think the red mic might be opened by the regie in a few seconds. Can you try it, Katie, so that we're sure it's working? It's not working. OK, so you guys want to share one of those mics. So actually, everyone talks about having this cloud-first strategy, but I would really like to know what cloud-first mean to you specifically and for your company. François, maybe first, what about Neosphere?
Yeah, sure. So Neosphere is a consulting company specialized in HR management, HR consulting. Initially, we worked with Cornerstone On Demand, a SaaS provider who provide performance services, learning services, and recruiting. And we help customers to implement their HR process into Cornerstone. It was initially what we done in 2011. After that, we detected different customer needs as administration, outsource administration, and also with Talend, data transformation. Transformation was the key point on a different HR project, and we help our HR customer to build and to implement their solution in a better condition. So it was all our partners are based in the cloud, and so it's natural for us to use cloud technology because we definitely have to be agile in our integration and into our implementation to help our customer. And we also bring disruption in the market to provide only services and not licenses. So we have to align our purchasing model in our sales model. It's why we chose a cloud solution. And all in all, it's our initial strategy to work on cloud.
Thank you very much. So if I heard you correctly, it's all about agility first. Let's share this mic with Katie, if you may, for a quick second. And yeah, Katie, again, when it comes to University of Pennsylvania, what cloud first means to you?
Right, okay. So I'm actually here with my colleague, Janet Lind, today. And we are both on a central IT organization within the university that we call Information Systems and Computing. And as a central IT organization, we support 12 different schools and centers that are very autonomous. So for us, we have to, we're basically a service organization. So we have to provide value-added services continually to make us relevant, I guess. So I think as everybody has experienced, the business wants everything cheaper, better, faster. So our Cloud First initiative started a couple of years ago, and one of the drivers was our data center was sort of reaching the end of its life span as to where it is right now. It's in an older building. It's not in a great location. We need to start expanding it. So the thought was, do we want to invest millions of dollars in infrastructure and on-site costs and everything, or do we really want to change our direction? So that's sort of what kicked off the Cloud First initiative. Again, cost savings. The other thing I think where we have a lot of opportunity for cost savings is in scalability, both up and down. And in our case, we have a lot of time periods throughout the year that are really spike volumes for us, so we're kind of seasonal. Financial aid, registration, even donations are very high at certain points of the year, but not throughout the year necessarily at the same level. So I think there's opportunity to not have to buy the infrastructure and have it be idle, 50% of the year, and this way we can scale up and down. So our first major undertaking was building a framework in AWS, on the AWS platform for custom development, and that has finished recently. And then we're starting to we've adopted a lot of SaaS solutions in the cloud, and then Talend, of course.
Absolutely. So it's more about a tailor-made approach so that you can actually manage the seasoning and the peak of data you actually need to manage every single month. But the previous speaker deep dived into what Talend Integration Cloud is, and it's really great for us because it's a great ground so that we can also build on this service. Because you selected an integration platform as a service and Talend Integration Cloud, of course. Why did you make that move?
Right, so we were going through a selection process for originally ETL tool, particularly for our data warehouse environment. And obviously, with the cloud-first initiative throughout our organization, we weren't going to bring in a whole bunch of servers and try to stand up something locally. So one of the key criteria was that there had to be some cloud presence. And Talend Integration Cloud offered us that. And when we saw the product and we saw how it worked, we realized that it would really free up a lot of our people to do more value-added things than managing servers and that kind of thing. So the other thing is we're on this journey, like I've heard a lot today, with no finish line. So it's going to take us years to get to the point where we're completely cloud native. And Talend Integration Cloud offers us the ability to have a lot of our key applications still on-premise while we move things to the cloud, and not have to completely re-architect every time we do that, because it's happening more and more frequently as time goes on.
And specifically about the iPaaS strategy, if we zero in?
So iPaaS, again, it really aligns with our strategy. The more that we can offload the tasks of the nature of patching servers and upgrading software, the more we can free up the people that we have. And in a university, you kind of have a flat number of people that doesn't change up and down very frequently. So we need to use the people in the best way that we can. So the idea with the iPaaS is sort of offload all of that and focus on the really valuable stuff, which is data and analytics and enabling applications.
So we have recent Bring Your Customer with the Acadian University of Pennsylvania around the table, because you actually joined this service earlier this year. It was back in February, if I'm not mistaken. But we have another type of client. I mean, François, Neosphere has been client for Talend Integration Cloud for years now. And this story, I mean, teaming up with Talend Solutions, goes back to 2013, if I'm not mistaken. What business issues did you face at the time when you actually chose to go for Talend Integration Cloud when it was first released?
So we were already using Talend on-premise before the cloud release. We were using Talend to integrate HR solution into different platforms. To allow communication between leaves management system and learning management system in order to schedule easily the learning session. And we encounter difficulties with customer to work on server subject because we work mainly with HR services. And it was difficult for them to work with the IT to mobilize external resources. So when Talend proposed us to be their first beta customer, we seized the opportunity to work to go ahead on cloud, and we were able to go faster with our customer.
Seizing opportunities and beta testing. That's a great mindset. But now, if we actually fast forward to 2017, to the year we're out, just now, of course your business has evolved. So what do you expect right now from an iPaaS solution?
Okay. So since the first release, we work and we use more and more Talend in our processes. So we would like a reliable solution, and we increase the communication between the different systems. We created migration services, for example, to allow customers to migrate easily data from Saba to Cornerstone on Demand without spend a lot of months on data transformation. Customer has just to provide us a dump of their system, and we standardize all the transformation, 90% of transformation, and the 10% left are managed during a workshop with customer, for example, to define rules on what is goals in SAP and what is goal in Cornerstone and Demand, and to implement this rule into Talend. It's what we are doing now, and also to improve the integrated solution, to improve employee engagement, to provide to end user integrated solution in the core HR system.
Thank you very much. Now let's turn to the partner around the table, and it's you, of course, Troy. AWS has been involved, of course, for a long time in the cloud and on many different products, several of them. Tell us a little bit more about the company culture that actually helps you coming up with brand new ideas of services and solutions in the cloud.
Yeah, so AWS, innovation is kind of really in our DNA. It's the structure and the organization that we have in place really allows us to, to move quickly and build a lot of different tools. We kind of start with, hiring builders, right? Builders are the type of people that are able to look at customer experiences, identify pain points, but then also be able to reinvent those things, right, and find better solutions. They're also folks that really understand that when you launch a product, that's only the starting line, right? That's not the finish line. So that's very important. Secondly, we have development teams that are fully autonomous and distributed, and they work directly with our customers, right? They're empowered to go talk to customers, interact with them, and also build and launch features and services based on those interactions. So that's a really big, important piece to that. And then, kind of lastly there, we use the same AWS building blocks that everybody else uses, right? So we sell these building blocks, we tell our customers to use them. We do the same thing, right? We want to get the same benefits that everybody else does.
You're the very first ambassador of your own products, right?
Correct.
So we have a lot of CIOs and managers in the audience, obviously, today. What would be the main takeaways for them to create cloud-first culture?
Yeah, so I think there's a number of ways, there's a number of things that you can do, right? If we look kind of top of mind, what we know really works for a lot of our customers, I'll highlight three things. The first one, you want to get executive acceptance, right? You want to be able to highlight the things that are most concerning to these executives and get their buy-in to move forward. The other thing we want to do is, we want to make sure that the IT team is fully bought in, and they commit to the vision. Right? You probably will get, some resistance, or maybe a little bit more resistance than usual. But
well, ask them. Let's ask them.
I'm sure some of you have gone through this. So I think, in that case, it's really important to clearly articulate the cloud vision that you're about to embrace on, and also provide your team with the right tools to make them successful, right? Asking them to do a lot and to have folks kind of switch backgrounds or learn new things is hard, right? So we want to be able to provide them with the tools. In AWS, we have a lot of training and support functional or services that you can leverage, things like certifications, boot camps, reInvent is great, but also interact with AWS individuals directly, like our technical account managers and solution architects, and that's going to help bring your entire team up to speed. So that's very important. And then the last thing is, sort of trying to get quick wins. That's easier said than done, but if you can look at some applications or workloads that are not easy necessarily, but are quick to migrate to the cloud, but also make sure that you can portray a visual or very visual benefits to the organization, right? So you don't want to just pick anything. You want to pick something that has an impact.
Yeah, so first thing first, always coming back to the purpose and reason why you're actually going to implement a cloud first or iPaaS strategy. Thank you very much for that. Now, I want to zero in the specific products that are relevant to big data and cloud data warehousing, such as Amazon EMR, for instance, Redshift, or S3. What kind of innovative use case do you have amongst your customers that you can share with us?
Yeah, so you know, the cloud has really made it easy for folks to collect, to store, analyze, and even share data, right, in a very cost-effective manner. But we're seeing, you know, a lot of customers, or at least one of very popular use cases these days, and I think a lot of folks talked about it today, is data lakes. Yeah. Right. So we see a large number of customers building out these data lakes using Amazon S3, but also Redshift is in the picture. We have one large customer in the U.S. That has built a data lake that incorporates Redshift for most recent or hot data, and then S3 for the cold data, and they're using Apache Presto on top of EMR to be able to query that cold data. You know, another trend that we're seeing that a lot of customers are kind of getting into is you know, basically real-time analytics and also predictive analytics. So we have a large customer in the US that has, you know, a very large real estate database, right? And they're running 7.5 million different machine learning models per day using Apache Spark ML on EMR, right? There's another regulatory financial body that does millions of transactions for anomaly detection per day. So that's kind of the top ones. There's many more.
Very interesting example, though we'll come back to you in a few seconds. But we tackle actually, Katie and François, the main reason why we actually go for a cloud-first strategy, and a lot of those reasons, of course, and the reason why company moved to the cloud is because of performance, is because of it shortens time to market, especially when it comes to dev, to test, to protocols. So what has been your experience with Talend Integration Cloud in terms of performance and time to market? Maybe let's turn to University of Pennsylvania first, Katie.
Right. So I'm a data warehouse architect, so performance is always like at the forefront of my mind. At Penn, our data warehouse is over 20 years old, so we have accumulated a lot of data. And we're starting to have situations where you know, our windows of time to update data are not big enough anymore, so it's always an issue. So now that we're not just moving data between, you know, applications and databases within our data center, we now have to go out to the cloud and come back. It's even a bigger concern. So one of the things that we've done is we, over the years, built a performance test environment that's almost the same size as our performance, I mean, our production environments for the data warehouse, which allows us to performance test. Now, I think performance testing is one of the things that gets cut from the project first when you're starting to run out of time. So with Talend Integration Cloud, one of the key features that I'm seeing as hugely beneficial to what we're doing is we can create jobs in the studio. We can develop them, we can unit test them, and then we can deploy them out to Talend Integration Cloud, run them in a dev environment, and using the context variables with Talend, you can change your environments at runtime or at schedule time, at deployment, whatever. So the same exact code base and job, you basically switch your environment, run it in test. Switch your environment, run it in performance test. Because I'm not able to run huge volume data sets on, you know, in the studio. So it makes it the life cycle really fast to be able to turn around changes in some of these jobs that are going after tens of millions or more rows of data.
François, what's your perspective on this time to market and performance efficiency of such solutions as Talend Integration Cloud?
So the first benefit wasn't the time to market, but was his time to decision making. Okay. Because previously we had a lot of opportunity without concrete decision, without concrete order from a customer due to the difficulty for them to project into an architecture in the way to reach their functional needs. So it's the first benefit for us. And after the decision, we also notice a reduction of 3 weeks on hosting installation, on server installation. And also when we deploy the different job from pre-prod environment to production environment, we could, it's easier. We have just to change the input and output component to go in live. It's more flexible than server on-premise solution.
Okay, so time to decision making, which is a great perspective, and of course the flexibility it allows you to have on such projects. Now, Roy, if we actually turn to the partner position when it comes to DevOps, of course using agile DevOps processes in the cloud has been instrumental in shortening dev, test, prod cycles, as we said previously, but what's your perspective specifically on DevOps, and what do you offer to customers to accelerate their own DevOps processes?
Yeah, so we know that DevOps, the idea of DevOps really means the separation of development and operation, right? We want to be able to kind of bring them together. So really, we're looking at engineers to work across the entire application lifecycle, you know, from development to test to deployment and operation. So we have a number of different tools that kind of go across the gamut of requirements there. You know, things like code commit and code build and code deploy that allow you in a development and test environment. We have, you know, many customers that are using code pipeline that ties them all together and gives you a complete continuous integration, continuous delivery pipeline. We have another tool that is called CloudFormation, AWS CloudFormation, that I would say, you know, very large majority of our users are already using it, and that allows you to take your entire infrastructure and define it in code. So you can still have the same development and test and auditing that you would on code, but for your infrastructure. And that makes a really big difference when customers are just starting to launch and deploy their infrastructure onto the cloud.
Thank you very much. We're about to head to the conclusion of this debate, but before we do so, I have kind of a crystal ball question for you around this table. What's your perspective on the future of cloud, Roy?
Yeah, so it's...
Let's open this crystal ball.
Yeah, of course. So, you know, we definitely see that, you know, at the end of the day, most of, you know, majority of the customers are going to move to the cloud. There's going to be very few customers that are going to maintain their own data centers. So that means a lot of the workloads and applications are going to move to the cloud. And for us, all that means is that we're going to continue to serve these customers the Amazon way, right? We want to be able to look at what the customers are asking for and build the kind of tools and services that they're asking for. You know, if we look at AI, right, artificial intelligence and machine learning, that's really been picking up lately. A lot of interest. I think every single customer that I talk to has brought up machine learning, that they want to do, either they're doing something with it or they want to do something soon. So, you know, we're listening to our customers. We're building the tools that they're asking us to do. We're building a very strong ecosystem around machine learning and AI. So, you know, listen to your customers and do what they ask you to do.
That's the Amazon way to foresee the future of cloud. But let's turn to the University of Pennsylvania Neosphere way to see what's going to happen in the near future. Again, what's your future plan when it comes to cloud, Katie? And more specifically, how do you intend to incorporate talent integration cloud to those kind of future strategies?
Right. So interestingly, even though we originally selected Talend for data warehousing and ETL, the use case in our video this morning is something a little bit different, and that was our first really highly visible deployment, and it was also our first cloud-native application that was built as part of this Cloud First program. And so I think what has happened is it kind of became a testament to this model can work, it can perform, we can turn the development cycle around very quickly, and we can deliver faster and higher quality and, you know, all the things that everybody's looking for. So I think that going forward, we're going to continue on the journey. I know that as far as Talend is concerned, a lot of people are now coming to us and saying, "Whoa, we saw this really cool thing that you did. You know, can we use Talend for this? Can we use Talend for that?" So, and then as the data warehouse architect, I have to now figure out, well, how are we going to, you know, rewrite all these old jobs that we have in old PL SQL and migrate everything over to Talend. So there's no shortage of projects coming my way, or our way.
Thank you very much. François, last word with you, if you may. What's your perspective on this future of cloud question? And of course, how would you integrate Talend Integrated Cloud to those specific projects?
So in human resources, the customer are using more and more SaaS solution, and their needs are to communicate, to allow the communication between different SaaS applications very easily without customized connector, but with a standard connector, and the capability to link one SaaS with another very easily without spend months to bring this functionality. And also is in HR system is the capability to build HR flow, HR services with different SaaS. For example, goals creation in IDP and goal evaluation into Cornerstone on Demand, because it's their needs, their business, and it's to be more agile in the cloud. And we are building more and more standard connector and to make things easier for our customer.
So solution that will actually blend more easily and seamlessly together so that you can actually better serve your customers in the near future. Thank you very much to you three. It was really great to have your perspective, your insights, and return on experience. I think you deserve some applause, right?
Thank you.
And without further ado, I hand it over to Laurence, of course.
Thank you very much to all of you. Thank you. So that was the last session for the day, but it's not finished yet. Because now for the announcement of audience winner and individual awards, I will ask the one you know, Mike and François, to come on stage.
So, Mike, I think we had to change the agenda a little bit before we announce the winner of the grand winner of the prize for today. Because we had so many questions and remarks during breaks about real-life examples, we thought that we would change the agenda a bit and, come with a surprise to you. Actually, there are two customers that we'd like to give you more information about, and especially real-life examples of what they've been doing with our products. The first example I'd like to introduce today is Crédit Agricole Customer Finance. So Crédit Agricole Customer Finance has introduced innovation in the way they grant loans and subscriptions using social media. And, well, I think the best way is to look at the video.
Let's roll the video.
Issuing credit is never simple. In an increasingly strict regulatory context, we're faced with an urgent need for monitoring. If a client finds us on the web and then pays us a visit at the branch, we have to be able to make their dreams a reality. That means analyzing their needs based on clean, reliable, encrypted data. Crédit Agricole Consumer Finance hinges upon the Crédit Agricole Group. Not only do we strive to issue credit assigned to specific products, we also offer revolving credit, so a portfolio that's based on your needs. As part of this, we still had many processes that were not computerized but were still in paper format. It takes 3 weeks to find a paper record if it's stored at a remote filing site, but only takes a few seconds to recreate a file in digital form.
We have undertaken a massive project to digitalize the company, entailing an enhanced experience for clients using our various digital channels, as well as a key project involving the provision of data, which is truly the heart and soul of our company, to our various collaborators, partners, and clients. When we opted to implement the big data platform, naturally we looked to Accenture.
Accenture offered us their know-how and expertise.
All data and information are collected with the client's consent. We had some legwork to do to prepare for this phase with our compliance teams, the CNIL, and our digital security staff. This preparation helped us anticipate the requirements of the GDPR. We process a vast amount of internal and external data. Our data intake capacity is equivalent to tens of terabytes per day. While older platforms took several days to process this amount of data, it took the big data platform less than an hour to complete the process. It goes without saying, Talend accelerated and facilitated the management of all of these IT issues. The big data platform was a true driver of new applications. The performance of our websites is monitored, enabling very detailed analysis of our internet users' trajectory from A to Z throughout our entire web ecosystem. The 360 client vision entails making our wealth of client information available to our collaborators at the branch or over the phone in order to help them customize their conversation accordingly while on the phone and get in direct touch with our clients. Another very innovative use of big data is the granting of credit by social networks. An internet user goes to the sofinco.fr website, does a simulation and chooses a credit product. We offer the client the option of using the pre-fill function with their consent if they grant us access to their Facebook or LinkedIn social media information. We use information from these social networks to better understand the client and facilitate the issuance of credit.
Integrating 100 times more data, especially external data, to be able to qualify our clients' preferences, to understand our clients' expectations, will ultimately enable us to significantly speed up the credit issuance process.
So we do have a second example that we want to share with you. This company is dealing with a completely different challenge. So I do have a question for you, Mike. Here is the deal. By 2050, there will be 9 billion of people on Earth. How are we going to feed them?
Precision farming.
Precision farming, that's probably the answer. And here is a video from SMAG with their innovative precision farming solution, which probably gives an answer to that question.
Roll the video.
To enable farmers to meet the challenge of feeding 9 billion people.
To produce more to feed all these people.
To predict events on farm plots. NVivo is the natural union of French cooperatives, with a total of 220 cooperatives, the first agricultural and agro-industrial group in France, and the second of its kind in Europe.
SMAG is one of these subsidiaries, active in the digital field. We launched an initial project called Data Crop, which allows us to monitor the crop's development and its yield. This is an ambitious project, the first French digital agricultural platform. We singled out GEMS as the company best suited to assist us.
We worked alongside SMAG throughout the entire project, which lasted 6 months. We started with the design phase. Next, we implemented the technical infrastructure by installing Hadoop and Elasticsearch. We then developed all the feed processes and the yield prediction algorithm. Finally, we went on to the production launch.
The SMAG platform houses more than 12 million hectares of the usable agricultural surface in France. Today, a 1-hectare plot is equivalent to 1 million data entries collected.
We handle an impressive volumetry, with a data lake that currently receives and processes 300 gigabytes of data per day, with 1 petabyte of data on the horizon.
We will collect 2 separate data populations. The first population is open data. Satellite data is a concrete example.
We also have weather data, more than 30 years of reference data records, including soil varieties and types.
SMAG's mission is to compile all this data and to integrate and combine it with proprietary data, issued directly by the user or by connected objects installed on the farm. there are countless benefits. Traders will be able to take positions on the world market prices faster and thereby anticipate price volatility. Next, regarding milling and harvesting, cooperatives or agribusiness merchants will be able to better organize the zoning of different grain productions. It will provide agricultural advisors and technicians in general with a tool to assist and guide the farmers. Finally, the most important benefit is for the farmer. Nowadays, precision agriculture allows farmers to very closely monitor their overall harvest roadmap at the interplot level to increase crop production while improving environmental protection. If farmers can optimize their farm's operating margins, we will have succeeded and accomplished our original mission.
All right. So now I would like to recognize some individuals that have demonstrated exceptional leadership and vision in architecting their data-driven future. And then after that, we'll announce the final winner of the Grand Award. So first, we'd like to congratulate Francois Avedian, who's the Operation Director. Francois, congratulations.
Thank you.
Félicitations.
Thank you. Merci.
Please look a bit more.
Yeah. Mettez-vous mieux, mettez-vous mieux, mettez-vous mieux, mettez-vous.
All right. So Francois is the Operation Director at, I need a little help here.
Mon portail RH, Mike.
It's very difficult. How would I not know that? How would I not know that? The first what's that? My HR portal, thank you, in the English translation. The first platform offering a personalized HR service in a SaaS mode. Francois was one of the first customers in Talend for the Talend Integration Cloud, as you just heard on stage a few moments ago. We're very happy to announce a new Talend European data center. So our European customers, like Francois, will be able to maintain their data inside the EU and meet the highest standards regarding data privacy rights of their customers, important in the new GDPR regulation scheme. So thank you and congratulations. We would like to congratulate Tobias Baumgart, a platform architect at Conrad Electronic. And after setting up a data warehouse, Conrad has delivered a significant number of use cases, including an e-commerce shop connection for all of their shops in Europe. And we're supporting Conrad in their migration to the Google Cloud. Thank you, Tobias. Congratulations.
Congratulations.
Next, we'd like to congratulate Dennis Bourdon, CEO at April Technologies, with our VAR partner, Kiris. Congratulations. Congratulations.
Bravo.
Designed by April Technologies and Kiris, C2X, which stands for Customer Experience Excellence, is a unique data-driven solution which brings together Cloudera, Qlik, and Talend technologies to mine data from every interaction point along the customer journey. And finally, we'd like to congratulate Prashant Huria, who's Vice President of IT at the enabling units of AstraZeneca. Prashant and his team built a huge data lake for all enabling units, the global product portfolio strategy, and the medical functions. Unfortunately, Prashant cannot be with us today. And now, for the moment that we've all been waiting for. By your popular demand and by your vote, the winner of the Grand Award for the Talend Data Masters 2017 is Congratulations. Congratulations. All right. And I want to ask for one last round of applause for all of our Talend Data Mastery Awards. Congratulations to all of you. And
it looks like the day is coming to an end. It was a pleasure to have you all in the building today. Thanks for the contributions, interactions. Congratulations to the winners. But we're not yet done with the day. I mean, we have one last final step to go to, which is welcoming you for drinks on the 3rd level, and it's now. If you wish to join us, I hope we see all of you upstairs. Congratulations for the winners, and have a good day.